Okay, in our last video we looked at factoring polynomials that were 4 or more terms, and I'd like to do a couple more examples of that. Alright, so let's review. To factor polynomials, the very first step is to take out the greatest common factor. The next step is to identify your polynomial. And the kind that we looked at last time was polynomials that were 4 or more terms. To factor polynomials that are 4 or more terms, you factor by grouping. So let's do another example of this. So here's a polynomial that's 4 or more terms. 12x squared y minus 21x minus 8xy squared plus 14y. Alright, I'm going to factor this, and I'm going to probably group these two terms together and these two terms together. Alright? Now when I look at these two terms, I see that they both have a 4 in common, and each of them has at least one x, and each of them has at least one y. So I'm going to take out a 4xy. So when I take out a 4xy here, I have 3x left. And when I divide this term by 4xy, I have negative 2y left. Alright, now when I look at these two terms, I can see that they both have a 7 in them. So I'm going to take out a 7. And remember, you have to write either a positive or a negative sign in front of the 7. So I'm going to take out a plus 7. And when I divide negative 21x by plus 7, I get negative 3x. And when I divide 14y by plus 7, I get plus 2y. Now, this happens often when you're factoring, where you get two expressions that are actually additive inverses. We can remedy this by factoring out a negative 1. We saw in our introduction video that you can change one polynomial into its additive inverse by factoring out a negative 1. And so that's what we're going to do. We're going to leave this term alone. And right here we're going to factor a negative 1 out, and we're going to put that negative 1 in front of the 7. So when we divide negative 3x by negative 1, we get positive 3x. And when we divide 2y by negative 1, we get minus 2y. Factoring out the negative 1 helps us to turn our binomial into its additive inverse so that these are exactly alike. We can't proceed until these factors are exactly alike, because now I have two terms in my polynomial, and they both have a common factor, and it's 3x minus 2y. So I will factor out the 3x minus 2y. And in this term I have a 4xy left, and in this term I have a minus 7 left. And I have factored my polynomial. Remember, you are through factoring when you have simply a product of either groups or letters or numbers. All right, let's do one more example. Here's a rather simple looking 4 or more term example. We have 2xy plus y minus 2x minus 1. Now, if I were going to group these, most students would look at this and they would want to group these two terms together because they see that they have a 2 in them. And that means that these two terms then must be grouped together. Alright, so we're going to take out what's in common with these two terms, and they both have a 2 and they also both have an x, so I'm going to factor out a 2x. Now when I divide 2xy by 2x, I get y. And when I divide negative 2x by 2x, I get negative 1. Now these two terms don't seem to have anything in common. I still always have to factor something out. When terms have nothing in common, we can factor out a 1. Or you might want to factor out a negative 1, either one, but you've got to factor something out. So here, they have nothing in common. I'm just going to factor out a 1. I need to write down my sign with my 1. I'm going to factor out a plus 1. And then I'll have positive y minus 1 left in parentheses. It is very helpful, not entirely necessary, but very helpful to write this way, because now we can see that each of our two terms has a common factor, and it's y minus 1. If you do not write this way, as a beginner, you're likely not to see that you have y minus 1 in common. All right? But y minus 1 is a common factor that I can pull out. So y minus 1, and then when I divide this by y minus 1, I get 2x. And when I divide this by y minus 1, I get plus 1. And I have factored my polynomial of 4 or more terms.